In this lesson, we're going to look at the graphs and zeros of a polynomial. So here it says a polynomial is a function consisting of terms that all have whole number powers. In its most general form, a polynomial can be written as this. So basically, each of these, n would be the biggest exponent. Let's say it's a 5, then the next term would have an exponent of 4, and so on until I have an exponent of 1, and then just a constant here, such as the number 10 or -2 or something like that. Some of these terms can be missing, which would mean that the value here, okay, would be 0, so we don't have to have every single term. We worked with quadratic and linear functions. They're the simplest of polynomials, with 2 as the biggest exponent for quadratics and 1 as the biggest exponent for linear functions. And here we're going to look at cubic and quartic functions with the highest powers of x cubed and x to the 4th, respectively. So I am going to graph each of these. Each of these is a cubic function because the biggest exponent is 3. This one has all 4 terms. This one's missing the squared term. This one's missing the constant. That doesn't really have that big of an impact on the number of roots, which is what we're looking at here. But we're just going to graph the first one. So we have minus 3x squared minus 6x plus 8. So this quadratic, and I'm going to set my window to match the -5 to 5, and then the -20 to 20. And I must have messed something up, so let's just look. Yeah, so I put it in the wrong place. The x scale should still be a 1, and this should say -20 to 20. Okay, so y min and y max there. So this one I can see that I have 1, 2, 3 real roots. And we're going to look at the graphs. Basically, you can just sketch this in. I'll have the graphs up in a second. Just to make this video a little faster, I'm just going to graph each one to look at it. So I'm graphing the second one. So same window, this one has 1 real root. Now we know that that means that there's 2 other imaginary roots because we know every polynomial of degree 3, a cubic, has 3 roots somewhere. So this is not one we could solve really algebraically with our methods, but there are still 3 roots, but only 1 real root. Our last one, we have 2x to the 3rd minus 12x squared plus 18x. And when I graph that one, we could say 1, 2 roots, right? Because it's tangent right here. But if we're counting, even though there's 2 numbers, there is 1, 2, 3 roots because this double root does count as 2. So those are our 3 situations. You should draw a sketch, but I'm going to bring up the graphs now. So here's those 3 graphs that we just looked at. And it says clearly a cubic may have 1, 2, even though we know this one really counts twice, or 1, 2, 3 real roots. And they can have 2 turning points. So 1, 2, 1, 2, 1, 2. Just as with parabolas, there exists a tie between a cubic's factors and its x-intercepts. So in the next problem, I'm going to go back to my blank one. We're going to look at our first cubic. So this is -x cubed plus x squared plus 12x. The general shape of the function, and this goes back to that first lesson about power functions and behaviors. Because this is an x cubed graph, I know that the 2 arrows go in opposite directions. Because it's -x cubed, I know it's going to go down. So I don't really know what's going to happen in the middle, but the idea is this side has to go up or point up basically, and the other side points down. Okay. Now it's going to be in a different spot. That's not perfect, but the arrows will go in that direction. The y-intercept we can look for at the end of the function, right? The number by itself. There is nothing. There's no like +5 or -2, so the y-intercept of this should just be 0. So I would have to fix my sketch and move that down. And now we're algebraically going to determine the zeros of the function. So just like quadratics, when we get the zeros, we're going to set our function equal to 0 because the y value, the function value, is 0. Now this one, we have a GCF, would be the first thing I want to do for factoring. I'm going to take out a -x to flip this to +x squared. That's going to flip each of the signs and take out the x. This is adds up to 1 multiplies to negative 12, so this is x minus 4, x plus 3 equals 0. Now this is not a constant out here, that's a variable. So we have negative x equals 0. So if we divide by negative 1, we would still have x equals 0. This one is going to give me a 4, and this one's going to give me a negative 3. So these are my 3 roots. It says to plot the zeros on the grid to the right, so I think I'm going to cross through 0, through 4, and then through negative 3. Now I don't know exactly what it's going to look like, but I know because of that general shape, I now know that it's going to come down like this and go like that because I know what the end behavior is. We're going to get a more exact graph, but we know that much about it just from what we have. We see the y-intercept is correct, is 0, right? Those are our 3 roots. So we're going to go to the calculator now. It says using your graphing calculator, find the relative maximum and relative minimum points on the graph to the nearest tenth. Bring up my calculator. And we have negative x to the third plus x squared plus 12x. I'm just going to do a quick check to make sure my mic is still working. So actually, I can't even see it from here. So we're just going to have to hope. Okay. So I have my function in. And then I'm going to change my window. If I look at this graph, it's negative 7 to 7 and negative 25 to 25. So negative 7 to 7 and negative 25 to 25. This graph. So I see exactly what I expected. The roots are exactly where I expected them to be. And it has that general shape. I wasn't sure about how high and low that minimum and maximum go. So that's what we're going to find next for part D. So we go to second calc. I'm going to do the minimum first. So the left side of the minimum, we have our 3 questions. Left side is over here. Right side is over here. And that's my guess. So this one is negative 1.7. Negative 12.6. And I'm going to write all that on here when we're done, kind of going back and forth to make the video a little shorter. So now I have to go again to second calc maximum. Left side, right side, guess. And this point is 2.4, 20.7. So I'm going to bring up that answer key with the graph on it. Just so we can see. Okay. So I'm actually going to write these down. I thought I had these here, but I don't. Here's the shape of that graph. We see this is a little lower than that is high. And I'm going to bring back the calculator and we'll write on those minimum and maximum points. Now I could write them down here with letter D, but I can also write them right on the graph, which I kind of prefer to do. You can ask your teacher what they want you to do. Let me just make this a little bigger so we can draw this on. So here's my graph. My maximum is 2.4, 20.7. That means this graph could be a little higher here, right, to kind of get up to that 20.7. And then this one down here, I'm just going to find that again. Here's a little trick for the left bound and right bound. I'm going to say the left side is negative 3. I can actually type it in. And my right side is 0. And I'm going to guess it's at x equals 1.5. So you can actually type in your guesses. That didn't work because I did not do negative 1.5. So second calc minimum, negative 3 for left, 0 for right, negative 1.5. I'm going to guess right in the middle for where it is. And there's my point. So it's negative 1.7. And I'm going to bring this down just a little bit more. So negative 1.7, comma, negative 12.6. So these are those minimum points that it's asked for in question D. I just labeled them directly on my graph. Sorry, that's a little messed up that the graph wasn't correct to start out with. I just kind of made it be a little more accurate to where those points were.